All right, we're going to talk about multiplication of radicals. And remember what we've talked about before with radicals is really a radical. It could be the square root of a number, it could be the cubed root of a number, anything involving the radical sign. Now we've already discussed adding and subtracting radicals. So in this example right here, we're adding and subtracting radicals, and the only way we can combine radicals is if they're like terms or they have the same radical. So notice in this example we have a radical 3 and a radical 3 here, so we can combine those. 2 of the radical 3's plus 4 of the radical 3's, that would give us 6 of the radical 3's. And then we have an unlike term, which is that radical 2, and this is all we can do with this problem, is just simplify it to 6 radical 3 minus radical 2. Also with radicals, we've talked about what I have in the green, and that's simplifying a radical. So remember, with this radical 24, this isn't simplified because 24 has a factor that's a perfect square root. So I can think of radical 24, and remember, well, before I do that, remember your perfect squares, such as 4, 9, 16, 25, and so on. Now 24, what's the largest factor that's a perfect square? And the answer to that would be 4, and I can think of 24 as 4 times 6, which means square root of 4 times the square root of 6. But the square root of 4 is 2, and I get 2 radical 6. And this is my final answer because 6 I can't break down to a factor that's a perfect square root. The only the 6 only factors of 6 are 1 and 6 and 2 and 3, and none of those are perfect squares. Now to finalize what we've already talked about, let's look at this last example. We have 3 radical 12. Now radical 12 part of it isn't simplified because I can think of 12 as 4 times 3. It has a perfect square factor. And this then, so I have 3. This means 3 times radical 4 times radical 3. But the square root of 4 is 2. And then 3 times 2, I get 6 radical 3. And that's what we've done with radicals so far. Now let's take it a step further and talk about multiplication of radicals. In example 1, we're multiplying 4 radical 3 times 3 radical 2. Now, when I'm adding and subtracting radicals, I have to have like terms, but that goes out the window when we're multiplying radicals. So when we're thinking of 4 radical 3 times 3 radical 2, what we do then to multiply radicals is if there is a number in front or a coefficient, we multiply them. And really what I'm going to do here first is I'm going to rearrange this. Really, this is all multiplication. So I have 4 times radical 3 times radical 2. It's all multiplication. So I could think of this as 4 times the 3 times the radical 3 times the radical 2. Now multiply just the numbers. So 4 times 3 is 12. Now how do you take care of this? Well, you just multiply the numbers inside. 3 times 2 is 6. So this, my answer here, or the simplification of this problem, is 12 radical 6. Now I know I'm done because 6 does not have a perfect square root factor. So 12 radical 6 is my answer. And so just to re-emphasize what we did, to multiply radicals, we just multiply the numbers in front. I got 12. And then multiply the radicals themselves. Just take the numbers inside and multiply them. 3 times 2, and I get radical 6. Alright, example 2, a similar problem. Now this time I'm not going to rearrange it, but let's just think about what we do. So I'm going to multiply the numbers in front. So 4 times 6 is 24. And then I'm going to multiply the radicals. And to multiply radicals, you just multiply the numbers inside. So 3 times 6 is 18. Now the only thing I got to do is make sure that the radical itself is simplified. Does 18 have a factor that's a perfect square? It does, 9. So I could think of this as 24 times 9 times 2, right? Because 9 times 2 is 18 and 9 is a perfect square. And this means 24 times the square root of 9 times the square root of 2. But what's the square root of 9? 3. So I'm going to take 24 times 3, which is 72 times the radical 2. And radical 2 does not have a perfect square factor, so I'm done. Right, now example 3 is a little different from the other two in that you've got parentheses. And anytime you have parentheses and something in front, well, that distributive property comes into play. So I'm going to take 4 times this, 4 radical 3 times that, and then 4 radical 3 times that. So I'm going to write this out. So you have 4 radical 3 times the 5 radical 2, and all I'm doing is distributing, plus the 4 radical 3 times the 6 radical 3. Now it becomes like examples 1 and 2. So I'm going to multiply these, I'm going to multiply these. So in the first part, 4 times 5 is 20. What's radical 3 times radical 2? Well, radical 6 plus, okay, plus sign right there. Now 4 times 6 is 24. And now to take radical 3 times radical 3, multiply the numbers inside. 3 times 3 is 9. Now, can I simplify 20 radical 6? Does 6 have a perfect square? It does not. But notice here, the square root of 9, well, that's easy. Square root of 9 is 3. So now I'm going to take 24 times 3. So let's see, 24 times 3, 72. So I have 20 radical 6 plus 72. And I'm done because I can't combine these two. They're unlike terms. They don't both have a radical 6 in them. Okay, now I did have, I thought I had another example, but I don't. But this is really the only other example I would have is a repeat or something similar to example 3. So we've gone through 3 good examples of the different ways or different types of problems of multiplying radicals.